All right, everyone, welcome in. Let's get started. So, it's obviously been quite a while since I streamed last. We're going to be playing with the camera angle a lot today, so I'm sorry if that gives anybody a hard time. It's been quite a while since I've streamed last. Um, the last PETI update was released in August or April, and I think that's around the last time I was live, and it's January now. So I think it might be good to sort of just recap kind of entirely what the project is. This totally isn't me using stream time as an excuse to pre-record some video to use for later either. But this essentially is PETI. This is a virtual pet that I have built around the MSP 430 family of microcontrollers. I've built it around a specific MSP 430, the 5994. FR 5994, which is just that's a way of telling you it's the FRAM version of the MSP 430, and then it's going to have certain peripherals attached to certain pins. It matters and it doesn't all at the same time. And very conveniently, I've essentially divided PETI. This is the PETI development kit, and I've divided it into the stuff I made and the stuff Texas Instruments made. And that's going to be important for understanding sort of what this pile of parts is, and also what our goal on today's stream is. But this is a virtual pet. This is, exactly in the vein of the Tamagotchis of the 90s, and then kind of rethought a little bit. It's not going to be like a modern Tamagotchi. I know the Tamagotchi is still in production. It's got this fancy color screen. Some of them have, I don't think it's Bluetooth, but like some kind of intercommunication technology. We haven't built any of that yet. We'll get to that. But it's a drive back in that direction of how these things were in the 90s. Black and white screen, very, very simple graphics, that kind of thing. So let's talk about what the components are as we assemble them. And once I get them assembled, we'll show you the pet, and then I'll talk about what the actual plan for today's stream is. So this is the core of the whole thing. This is what Texas Instruments calls a launch pad. And a great way of thinking about it, if you're familiar with electronics at the maker scale, but you're not familiar with TI's products, is this is basically an Arduino. That whole thing is sort of a class of technologies called a development kit, or a demonstration kit. In Texas Instruments cases, these are provided so that engineers can have quick access to a broken out version of the microcontroller to test them for various applications. And you can see this dotted line here. Everything below the dotted line is essentially the microcontroller and microcontroller accessories. And everything above this dotted line is what they call their easy FET. So this is actually programming hardware for these microcontrollers. If you had just this piece, or any other kind of FET, and you had a broken out microcontroller, you could program it, which is an important part of how the toy is going to work long term. We'll talk about that at some point in the future. It's not that important now. But one of the side goals of the virtual pet is for it to be sort of like a sideways introduction into doing embedded work and hacking on embedded systems or microcontroller based systems. The other very important piece that Texas Instruments provided. Oh, sorry, I've skipped a step. So the most important idea that you need to understand about this thing is that this is both the brain of the toy and the tool for having the brain talk to my computer so that I can program the brain and tell it what to do. That's all that's on here. This piece, this other red piece, is also a Texas Instruments product. This is what they call a boost pack. The boost packs are to the launch pads what hats are to the Arduino. No, they're not called hats. They're called hats for Raspberry Pis. What are they called when it's Arduino? Shields. They're what a shield is to an Arduino. And this particular one is for a little TFT, which means it's illuminated from light being reflected off its back. TFT Memory LCD, which is a product that Sharp develops. This one is 128 by 128 pixels square. And the easiest way to think of that is that this this module, not the entire red piece, but this piece here, the actual LCD module, contains its own control hardware. Which is important for keeping the toy small, and it's also important for making it easier to interact with because we just send serial data to this screen to draw on it. And it also is supposed to be lower power. We're going to get talking about power in a little bit because we have some power problems with this toy. And the way I've designed it, well, the way they've designed it really, is you can just slot them together like that. Bob's your uncle. All these pins are standardized and they all pass through, so you can make, I don't want to say an infinite stack because you start having to deal with like impedance and resistances and stuff, but you can make a pretty robust stack of devices. So, Texas Instruments has provided us a screen and a brain. But that's not a very good virtual pet, so we had to make some other stuff. And the first piece I designed was this thing. I call it the control daughter board. It could not be a more simplistic device if I was trying to create one. So this is just 4 switches, little momentary button switches, and capacitors to make their signals clean. That's it. That's all it does. And that snaps right on to the top of the TFT screen, which is kind of, it's been annoying to film with because it casts shadows through onto the screen. This is also it's getting quite chunky, right? Like a hand for scale. But that's just those parts, and it's already this big, and we still have this monstrosity to talk about. So this is the rear expansion board. You can see on the bottom, if it'll ever focus, I've marked it out as prototype revision C, because it is. This is the 3rd time we've designed this backboard. And it's honestly pretty simplistic. It's got 2 light trains, so just an LED and a resistor to limit the current passing through the LED. And of course the pins to hook everything up. It's got a piezo speaker, which is actually the wrong piezo speaker. That's the spec calls for a different little speaker and a transistor to drive it, which is part of kind of where I'm going with this only being revision C. Batteries, 2 AA batteries. It's designed for nickel metal hydride batteries, which are only 1.2 volts. And some stateful switches here. These control whether or not the device is in debug mode, whether or not the audio train's allowed to be used, and whether or not battery power is being passed, which is an important consideration. And then finally, actually not quite finally, there's also some power management circuitry, this little surface mount device, and all this crap that I've jammed into pads that are the wrong size to program this device. Basically, it takes the like 2.4 optimal volts coming off here and boosts it up to the 3.3 volts that drive everything else. And I think that might be part of our problem. I'll talk about that. And then finally, there is this expansion header coming up the top, and you can actually see that each pin is labeled. These 6 pins will be present on the final device. So it's the 4 pins. It's a ground pin on one end, a 3.3 volts positive pin on the other end, and then the 4 pins in the middle are a SPI bus. So there's the MISO and MOSI data lines, a clock line, and a chip select line. That will be present on the final like pocket toy version of the device, because one of the goals is to have little accessory like backpacks that you can clip on to the toy, and like say you want your version of the toy to have a pedometer, well, you just click the pedometer add-on to the back of the toy, and now it also counts your steps. On the dev kit, though, on this version of the dev kit, and I want to preserve it for future versions of the dev kit, there is also a pin for the LCD chip select. Because the same SPI bus that drives everything else drives this LCD and paints the picture. And if you have that, I don't have it set up, but I'm going to switch to a view where you can see where it would be. If you see that box up in the corner that says live SPI capture, no signal, if you actually listen with like a logic analyzer to the SPI bus and take the data and decode it, you can capture video off of the PET and put it in a stream overlay. It's really janky. It's a bad idea. The way I do it uses way more RAM than would actually be required, but that's what we do. So yeah, that's the virtual PET. And if you snap them together, the way I've got them set up now, even with just these little batteries in, he boots up just fine. And you can see the screen is quite clear. It probably doesn't look that clear on the camera just because like focusing's a bitch and so is lighting it. But yeah, we'll just clear the data and we'll set an arbitrary random time. And I forgot to put on debug mode, so we go to the egg. But it works exactly like those old Tamagotchis, right? This egg is going to try to hatch. It's going to yell at us when it's done hatching, and we're going to get to play with it. And that's where we get into problems. So there are, as I see it, sort of 3 or 4 problems with this device, the way it exists now. The first is that it's actually pretty heavy, although I don't truly mind the weight. Like, I want to say 80 or 90% of the weight is just the weight of 2 nickel metal hydride cells strapped to the back of it. Like, they're pretty dense for however much mega amp or milliamp hours they carry. But that just sort of starts the problem. Like, it's bulky. This does not shove into a pocket well. It also, without a case where it's got all this like leverage and stuff, I would not trust this in a backpack or a laptop bag or anything, sort of the sort. So I can't take this with me anywhere. And for me, that's a problem. Because there's no software environment on the computer. Like you can come over here to VS Code where we're writing our code and write all the software you want, and you can compile it on the computer. But because the architecture of the MSP430 microcontroller is itself unique, and obviously all the peripherals are unique, it would be a project of greater complexity than designing this device to build an emulator for this device to run the software on. So you need this if you're going to do any like serious development, right? Which is less than ideal. It would be nice to be able to carry it with you. It would also be nice for the purposes of playtesting, because we're getting very close to a finished feature set. A lot of the development from here on out will necessarily involve playing the game without skipping from portion to portion and making sure that everything feels right, making sure it feels okay, that the toy bothers you the right number of times per hour to feed and clean up after the pet. You know, you got to get that feel right. And we can copy the homework of other projects in that regard to a little bit, but we're gonna have to play test it. So, problem number 1, it's too bulky. Problem number 2, as I mentioned before, this is the wrong speaker. At least 2 firmware versions ago, we kind of formally deprecated this style of speaker. It still works for values of works, but it's not what the project expects to be there. Future versions of the hardware kit have an actual proper speaker. This buzzer is locked to a specific frequency, whereas the correct speaker that's supposed to be there, you can use pulse width modulation, sort of like an old PC speaker, to get pitches out of it. And then if you have that plus, you know, a clock of some description, you can write like actual music to play out of the speaker, which is not possible with this hardware. So that's a bummer. So we've got a device that's too big, we've got the wrong speaker on it, and we have a device that is fragile. Like the decision, it almost seemed to make sense at the time, then obviously in retrospect was a poor choice. This board is god-awful. I feel like I'm going to destroy it every time I take it off or put it back on, which I have to do because of the size of container. Like, this thing is... I always have a rule. Okay, I usually have a scale right here at my desk, but I don't have it right now for some reason. Oh, there it goes. He's hatching. I don't like that animation for he's hatching, actually. I'm going to send myself a quick note. The evolution animation sucks for a hatching egg. Okay, but anyway, the gist of it, this is a bad design physically. It has to be redesigned a little bit anyway. And the kind of final direction I wanted to take that in is that the battery on this toy does not appear, and I mean the word appear, the battery on this toy does not appear to... Oh. Wrong switch? Yeah. The battery on this toy does not appear to last nearly as long as we would have otherwise expected it to, based on the amount of battery that's there. Now I've got two cells wired in series, so I should only get the capacity of one of them. And up until now, I was admittedly working with a less powerful pair of batteries. I had a very old... They were lower capacity to begin with, and they were also very old. So it's entirely possible that that is a figment of my imagination. I don't like that I don't know for sure how much power this thing consumes, because the goal of the current hardware development push, the current sort of revision of the hardware, is to turn this board, and this board into one accessory board that mounts on either... I think it'll have to actually mount on the back, which is going to be fairly annoying, but it has to mount onto the brain board. And the reason for that is actually... I don't want to say simplistic, but it's there's kind of two reasons for it. The first is if we can get that stack that much smaller and that squared off, we can install some standoffs in the corners. The whole thing can be made reasonably robust for the purposes of, you know, firing it in a backpack alongside your notebooks and taking it with you to program, like even just somewhere else in the house. That'll also better serve, if it's nice and compact, it'll better serve the idea of doing kind of an extended playtest where it tracks, I don't know, for doing things like testing how long the battery lasts. But I shouldn't have done that way. Oops. The reason that is a problematic idea is basically these AA batteries. They won't... The standoff lengths aren't right if I put them in underneath, and I'm pretty sure it's even worse if I go this way, which I was considering doing. But basically, 2 AA batteries is just too damn big. If the goal is otherwise to get everything onto one board. And, to add to the problem, those batteries are not powerful enough, even with the proton pump thing. It's not a proton pump. The buck converter. It's not a buck converter either. Even with the power management IC installed, I can't drive the EasyFet. I can't drive the toy from the battery if the EasyFet is connected to power, and that's controlled by these jumpers up here. So one of my earliest thoughts was maybe to find like a multiplexing switch that's part of the accessory board that can be used to control. Oh, and look at that! It remembered where we were, so that function still works. I see that we're dumping debug to... Oh, probably because I turned debug mode on? No, debug mode is off. I don't know why that was happening. So we're writing into buffers we shouldn't write into, which is already a great sign. There's obviously still firmware issues with the device. But all this is to say, I've rambled. All this is to say that before we can make any serious decisions about the final design of the expanded dev kit, before we can make any determinations in that regard, I need to know more about what's happening under the hood of the power. Which is going to involve a lot of turning things off and on again. So there was already going to be... This is old news, right? This is news at least as old as last, like, spring, that there's going to be another version of this board. But I think longer term, one of the things I want to kind of accomplish with it is to... How can I put this? One of the things I want to accomplish in testing is going to be determining whether I can get rid of these AA batteries or not. I feel like I should be able to, right? The real Tamagotchi, I have one right here. The real Tamagotchi, which this is not much more complicated than, runs on... I should not have done that. Right, it runs on a CR2032, and it'll run for months. Like, I could not actually tell you when I put the battery in this thing. It must have been months ago. So I shouldn't be... Like, right now I'm getting, like, a day or two out of a pair of batteries. Or at least I was on the last batch of batteries I had. So we need to figure out why that statement is true. And we're going to do that by just taking a mountain of measurement. I bought a whole new pack of multimeter leads for this. I also, somewhere around here, have some jumpers we're going to install. And basically, from now until I get the answers I want, we're going to be working on that. Oh, I took this apart in the wrong order. The other thing that isn't really helping, I need KiCad open. I'm not going to show you guys the KiCad schematic, because frankly I don't feel like setting up another scene. But I do need it. Boy, I hope this is right. Yeah, okay, that's right. So I need 1, 2, 3, 7. I need 14 jumpy cables. Well, I need 13, I guess, because I'm going to be taking measurements in the way that you do. And I'm going to probably have to build a little breakout to do it. In fact, I know I'm going to have to build out a little breakout to do it, so just bear with me. Which one actually goes to the ground pin? It's that one. Okay, so yeah, so one of the big kind of tricky business pieces here is that this device is not well designed from the perspective of somebody who wants to do what I'm about to do. We're gonna sort of do our best with it, though. Yeah, power's off. Okay. Oh, you can't see what I'm doing anyway. Let's just 16, 18. 4. Okay, 4. What's that? 8. 10. 14. Alright, that should do the business. We may still have to get a little creative, so I won't take those too far away. Okay, so basically what this first experiment is going to consist of is just wiring up yeah. This, by the way, doing this this haphazardly is a great way to blow out a piece of equipment. Don't be that guy. I know you want to be that guy, but don't be that guy. Don't do what I'm doing right now. I'm an idiot. Okay, so clock comes from... Well, do we really... Do I have to wire everything up? Yes. Yes, I do have to wire everything up, because if I don't, I'm going to break something. Okay, so 3 not connected, and then the 4th one connected. 3 not connected, and then the 4th one connected. Oh, this is going to be just nasty to work with. I'm also going to take apart... This is from something I built ages ago that serves no actual function. So I'm going to take those lines apart when I have to. The one immediately above it becomes chip select, which can go from there straight to there. Oh, that one's broken. Interesting. Okay, then I need expansion chip select, which is a signal to nowhere. I'll take this apart. Sucks to have one that's broken, but that's fine. Okay. LED alert. To LED alert. So the reason I have to hook all of them up is kind of twofold. The first reason is that I don't actually know what the effect of leaving some, like some of these are outputs, some of them are inputs, but leaving them floating, actually almost all of them are outputs. But I don't know what leaving them floating will do to the software, and I want this thing to run as close to normal as possible while I'm taking these measurements. Obviously, it's not going to be, you know, perfectly normal. And then that ground is on there. Okay, so that's that one solved. This other one should be a little easier. So I need, essentially what I'm saying is I need these electrical connections, other than the fact that they're longer and then have slightly more impedance and resistance. I need them to be as close to, like, I guess factory, for lack of a better term, as I can get them. Ground. Okay, so signal debug, signal mute. I don't actually remember what LBO is. But it, oh, it's the low battery indicator. That's a bad tag. I should not use that tag if that's the tag. All right, and then buzzer. And then Mosi and Miso. Now, why would I be putting the clock? Mosi and Miso are going to be like dead signals. One, two, three. So the way Mosi and Miso work. I mean, it's SPI, right? So one, I don't like the terminology that's actually used in the spec. So the way I've been saying it is main in, secondary out. You can probably guess what the official terminology is, but like one line is literally messages for the controller or the main, and one line is messages or sorry, I should put it the other way. Messages from the controller and messages to the controller. And then a chip select signal controlled by the controller determines what device should be either listening to it or speaking to it, which can technically run in parallel, although I don't think my microcontroller would actually support that. Alright, now we have to deal with something uncomfortable. I have to find microcontroller leads that will do what I need them to do. Actually, so that's one I'll use. We're probably going to just discard, now that I've broken these out, actually, we're going to discard my old leads, because they were kind of flaky anyway. Oh, no. Oh, good. Okay. Auto power off saves me again. So, discard those leads. I don't need them. We will find some other, ideally very good use for them. Oh my god, these ones are horrendously long, though. That could be a problem. Black to black. And then I want... Oops. Hope this is correct. Oh yeah, they're just banana jacks. Okay. Alright, so step one is to assemble my new lead package. And then step two will be to actually connect. So I think, yeah, that should suffice. So I don't know how visible this is, but there's little flat that I can just tweak. Oh, this feels like a horrible idea. But then how do you... So you're not going to screw on, are you? No, you're going to have to go on the banana clip? Is that where that goes? I've been playing a lot of... this is not screwing in for some reason. Ah, that's why. I've been playing Elite Dangerous lately, so I get a fair number of messages that correspond to that. Alright, and then you can hook on my 3.3 volts out, which is right there. Now, in theory, that's smart. Oh, you know what helped? It helped to turn the meter on. I bet you no signal will pass through the meter if it's not on. So... Oh, and you can't see the meter, which is the most important part of this entire experiment. This is a janky experiment, even for me. My goodness. This is that business of the hard drive all over again. I'll have to dig up that clip sometime and use it as like a horror show demonstration. We're not passing through. Shit. Oh, we're trying to, though. 6 milliamps. That's way more current than should pass through there. Okay, but that raises a significantly sketchy question. Which is, with all that wired up like that, why do I still not get a signal? So... Ground is janked to ground, yes. Ground over here. I knew I shouldn't have used the same color lead for both. Let's at least pull it out of the wires so that it looks correct. Ground to ground. Yes. Signal debug to debug, yes. Yellow, black, brown. Yes. Wait. Yeah, yellow, black, brown. Yellow, orange, yellow, orange. Brown. Purple? Yep. Yep. Alright, so those are all connected in the right order. But something about that doesn't want to boot. I can see it thinking about it. But it doesn't want to boot. So, let's have a thought how we can make this saner. Fuck, I don't want to do it, but sanity check number 1 is going to be continuity testing, so let me take that off real quick, and it's going to have to go to what's it? Stiff banana. All right. So in theory now, sucks a little bit. I've done saner setups for tests. Okay, so we have continuity there. We have... This is going to be the easiest way to do this, isn't it? You have to test each one of these lines for continuity and then plug it back in. Which is kind of annoying, but the safest way to do it at the same time. Continuity. Wait a minute. Wait a minute. Okay, take this whole one apart. I fucked up. Okay, so it's gonna be ground to ground. And we're gonna take this one out because they can't be allowed to be next to each other like that. That's how I got confused in the first place. Signal debug to signal debug. Signal debug to signal debug. Mute to mute. Aha, I'm seeing a pattern here. Of course, now the new concern is, did I damage anything by wiring those up wrong? And I don't think I did, because they're all no connects. Yeah, they're all no connects on the back plane, so it doesn't really matter. Right? LBO. And buzzer. And then come down 4 disconnected pins. 1, 2, 3, 4. 2, 3, 4. Okay, so let's try this again. Going to the 60 megamp or milliamp. Whoa, why am I saying that wrong so consistently? So this is another thing that's really annoying about this design is that, like, it's not really fit for purpose in terms of when you have to take it apart like this. Admittedly, the dev kit is not designed. This was not a contemplated use of the dev kit. Okay, so I'm passing power. I'm still not getting video on the screen. The power that I'm passing is around 6 milliamps. And I'm not sure how I feel about that. How does that track up with the old numbers? Gotta get it. Oh, that's a little too old. Wrong grimoire. If you weren't already familiar with the way I work, I do a lot of work. Analog paper sources, because I mean, I just do. It's just convenient for me, I suppose, is how I want to phrase that. So now, did I screw up the same way here? Ground. Yep, I did. Nope, no, I did not. Let's think. What else could be wrong? Let me start by finishing the first thought I had, which is to check. I took some really crummy measurements at the end of last year. Current draw is roughly 20 milliamps. Well, that's not true anymore, is it? Or at least it wasn't true when it booted. Now, was it? So, the problem I'm having, I have to do this measurement. I have to. Because what I'm measuring on that measurement is the voltage provided, no, the amperage provided. I'm going to just have to test all these lines again. Okay, the ground has like half a ohm, which is plenty. And that goes. Oh, wait a minute. Yes, from there to there. Why do I see a floating... What is that? LED battery? That's not an important one. Okay, this is the other line that could be the problem, though. So, one of those lines is the LCD chip select. The other one, this one that I'm holding in my hand, is the SPI clock. And if the SPI clock don't work, you don't have a signal. And the problem is all these nice little jumper lines that I bought here are from a really cheap vendor. They're all sort of poorly constructed. So the other possibility that I have to worry about is you know, am I passing current? Like, just because they have continuity doesn't mean they're getting a good contact on the... I still have no video. Oh, I tell you what would be a helpful test. No, we're not actually posting. Something is flaky. Okay, you can't see it because of the way I've got the lighting set up. I have a status LED on the brain board itself that when it's actually... I'm going to just permanently jumper it in. And we'll see if we can see it. So this... See how it's blinking kind of irregularly? It's supposed to be a steady, like a 1 hertz blink, blonk, blink, blonk. And we're not booting up. So something somewhere is passing bad juju. Up the stack and causing it to reset uncontrollably. So it'd be nice if this wasn't twisted. Hold on, let me try and rearrange a little bit here. I really hope the audio is okay. So, part of the problem that's making this difficult is me, as usual. So, let's flip that over. 3 unconnected, then the yellow to the clock. Then the purple to the chip select. 3 unconnected. Then the yellow to the clock, then the purple to the chip select. And those are also set up. Black, blue, purple. Okay. There is a reset pin. Have I accidentally bound the reset pin? It is ground 574453 74453 reset. Okay, I'm not really touching the reset pin. That's a good sign. So the problem I get myself into, trying to take the measurement I want. Let me make sure this is even the measurement I want, now that I've said that. This might not be it, Chief. I might have just wasted like 45 minutes of everybody's time trying to take the wrong fucking measurement. We're going to take a quick ad break while I check my notes here. Partly because it's time, according to Twitch, so we'll be back in a couple minutes. Current measurements, 3.3 volt after regulator. Yeah, that's what I thought. So... Oh. One, two, three, four. Ground. 1, 2 with 3 underneath. 1, 2 with 3 underneath. 1. 1, 2, 3, 4. And they chunk straight down on like that. So that is actually correct. This is actually correct. So this presents a new problem. Anytime you want to start ad so I can explain myself without interrupting the poor folks at home. Okay, so... where else could I measure this that I would get the same measurement? That just introduces more moving parts. So where I'm running myself into trouble here is that how can I explain it? Well, I guess I got 3 minutes to figure that out because the ad just started. One, two, three, four. 1, 2. 1, 2. Brown, black, brown, black. Even if those were mixed, it shouldn't break anything. Right, the correct way to take this measurement is to whack it into current measurement mode. Take this probe and shove it up there. Oh, now it's posting. Not real well. Okay, so we're sitting around. Yeah, we're sitting around like 6.8 to 7. I have to put some error bars on here because it's wobbling. Six, 4, and then ramping up to 7. 6, 4, and then ramping up to 7. Okay, so that's a number. I need to write that number down. This is the sound of me waiting for an event that will never come. and wishing I had a larger desk. Alright, welcome back from the ad break, guys. I just kind of reseated some pins and now it's working. You can see that there's movement on the screen. I've got my heartbeat. I should actually uncap that heartbeat because it's going to affect the measurement. Whoa, it affects the measurement considerably. It affects the measurement to the tune of like 0.5 milliamp. Alright, so now it is very, very stable. That's great. So I have to write this measurement down. This 6 point... I'm going to call it 6.5 because I don't need the tightest error bars in the world for what I'm doing. 6.5, 6. Okay, let's call it 4.8 milliamp measurement. So I think I just didn't have that seated very well. So yeah, that was the measurement we needed here. .48. Quite consistent. So yeah, actually that's interesting. So if that was very consistent. That's the wrong pin. Hopefully I didn't kill anything by doing that. Okay. So, see how that's nice and stable? It's sitting... Sometimes when it's thinking hard, it climbs all the way up to like 6.5. Right? I'm going to plug that LED back in. And you can see that it ramps quite consistently when that LED is lit. That LED is a significant source of current draw. Which is interesting. But that's just one measurement. I'm kind of trying to rule out the measurements sort of one at a time that I need. Because I need them all. Goodness gracious, this is going to be an uncomfortable process. I figured that we would spend maybe 20 minutes on this, and it's turning out to be considerably longer. Okay, so the next one I want to check, you can't really see my notes here as well as maybe I should, just because of the way I've set the desk. But if you could see my notes, you'd see that I've listed a set of measurements that I want to collect. There's a lot of glare because there's a light here. Without this light, the camera can see, but it gets blinded by its own shadow, so we have this light to kind of balance everything out, which is making a really cramped workspace, but that's okay. So I think the next big culprit I really wanted to know was the LCD power, which is annoyingly enough not on this setup. So let me think really hard. Do I want... I don't want the... I don't want to bother measuring the LED current draw because I can calculate it. That's very simple to me. Let's calculate... I want to calculate the LCD power. Or I want to measure the LCD power and make sure it matches my calculations. If it matches my calculations... MCU worst case. Yeah, where is all this current going? Digital output high out to 6 milliamps. Unplugging display module drops consumption to 14 milliamps. Need to test individual circuits. Okay, so yeah, I was able to take some of these measurements before with my old leads. And just not be quite so precious about it. But obviously not all of them, so I'm going to need these still. Goodness, what a mess. But I think we're done taking measurements off the back plane, so I'm just going to disassemble this really quickly. And I'm going to grab the LCD chip select. So yeah, let's go over... These are the findings from last time, because I've been thinking about this problem since about October. So, at the time, the total current draw, which was measured, the way I measured the current draw was I whacked my probes between the positive end of the two batteries together and the terminal on the battery box, because it's exposed. It was really janky. I don't recommend doing it that way. And I got 20 milliamps total. But that's not fair, because all that current runs through this IC here, that little guy, and changes voltages. And the problem is, all the datasheet current draw that I had was for that changed voltage, which I couldn't measure up until now. But anyway, per the datasheet, I should only be drawing about 40 microamps for the display. So when I put I'm going to put myself between the display... Oh, this is going to be so gross. Between the display board and the... This is gonna just suck. Why am I doing this? Okay. Anyway, if I take a measurement on the right spots, I need a different clip for this. Which I think fell under my desk. Which is going to be kind of weird to retrieve. You probably saw me on camera doing that. Uh-oh. Did I lose my video? We've passed the 1 hour mark, so maybe I lost my video. Let's grab the mouse that controls this computer. Just too many fucking things on this desk. Fantastic. That video was dead air after the first hour and a bit. That's okay, though. We'll put on another... Oh, it's me! There was nothing wrong with the video at all. I yanked my headset out of the... There we go. Well, now we get new video. Anyway. I need the other banana clip. And I need the little wrench. Alright, let's move some stuff out of the way. The trick to working in a small space is staying organized, which this is not me doing. Alright. And give me this one. I actually watched on Christmas Day. Well, Christmas, like the night of Christmas Day. I watched The Thing for the first time with my brother. Because they very graciously let me blow up an air mattress in their living room. So that I didn't have to stay. My parents' house does not have room for me to stay when I go home. Because they live with my grandparents now. And my mother-in-law was ill, so I had to stay at my brother's house. And we watched The Thing. It was a delightful time. Absolutely hilarious movie. by the standards of now. I can easily see how, by the standards of the time, it was probably quite horrifying. The practical effects look absolutely fantastic. It's actually a great movie if you've never had the pleasure. My understanding is that in show business they call that vamping, by the way, if you're trying to figure out what it's doing. Oh, where are we at? I'm getting sore here. It might be Tylenol o'clock. At a watch me lose my Twitch channel for taking an over-the-counter medication on film. I'm sorry if anybody's watching and you have a sensitivity to like thoughts of medication or whatever. I believe in better living through pharmacology, and I really hurt my back last week, so... Right, we gotta figure out how to jump these. So I guess let's start doing it. At least on these ones, they're labeled on the silkscreen. So I just have to remember the crossover. This will also allow me to test a theory that I have, and that theory which one did I want to measure? Do I want to measure LCD display or LCD power? I probably want to measure both. Yeah, and the chip select. Alright, so we're going to take 3 measurements in this setup. What was I talking about? 1, 2, 3. Boy, I'm getting too old for this. I'm starting to understand why so many people appreciate those magnifying visors. I want one for soldering, but I'm starting to want one just for doing this sort of thing. LCD chip select. So one thing I do really like about this setup is that it's this design that TI came up with. These are stacks. Like, these pins are just passed through all the way up and down, like little, you know, one filament buses essentially, which can be really... Shush. We're still taking measurements. Actually, yeah, I'm gonna shut it off while we wait. Which can be really convenient for designing with them. And, like, obviously the goal is to eventually get this whole toy off of this stack and running as its own standalone pocket thing, but if you just wanted a microcontroller for, like, a prop you were building, this shit here is pretty straightforward. Oh, is that actually connected? Oh, I don't know what that does, is the problem. Next comm in. Wired up anyway. I'm pretty sure it's common to the ground. I'm pretty sure I looked it up, but who knows? Who knows how any of this shit works anymore? Not me. I'm just the guy who built the damn thing. I guess first things first, I'm going to proof of concept the harness by wiring in the measurement I want to take. And then I will test it, and then if I get a signal, I will just take it back out and replace it. Dolly clips, or whatever you call those. But I did want this proof of concept that not having anything on the 5-volt bus actually works. Shit. Alright, something's not working. What's not working? Help me, Obi-Wan Kenobi. Oh, whole toy's not working. Oh! I don't know if you're going to be able to see that. See that shiny pin? Yeah, you shouldn't be able to see that shiny pin. That breaks everything. Okay, we have a beating heart. We're not getting a clear enough signal. Oh, and we don't actually have a beating heart, so we're not progressing as far as we should. We're getting ourselves jacked up somewhere. Let me think. Oh, you know what would probably help? Grounding that side. Usually have to put both grounds on. There we go. Signal. Signal and blinking lights. Oh, we're not going to get any button press pass through because I didn't wire up the buttons. I don't feel like looking up the wiring for the buttons. They're not really going to matter because from here on out I'm just going to look for a signal, and if I see one I'm going to take it. So, first thing I want to check the math on LCD power, because I kind of don't believe the number I've been quoted. If I'm right, it'll show up in this range. Oh, I didn't want this. Damn it. I have to switch it back. Continue vamping. So this is going to be kind of exciting, and hopefully we'll be able to talk about it more on Thursday during the writing stream. But I have a book coming out. I clicked the please put this into production button like a week ago. But Drive-Through RPG are really far behind. They're who I'm going through for this book because it's a journaling RPG. So, you know, it'll come out when it comes out, I guess. I'm hoping it's out in time for our next stream, but you never know. Continued vamping. Uh-oh. Well, that ain't the right pen. The whole reason I bought these, this was the problem I was running into before. I did not have leads that were fine enough that's too fine. I did not have leads that are fine enough to extend down into these connectors. And without that, this was just going to be really difficult. I had actually briefly considered like making up a custom probe by like soldering a bit of wire to the thing. Not solidly recommended. Alright, hopefully you're in there. Hopefully I didn't break anything. Wow, really? Really? Damn, that is basically as quoted. Basically as quoted. Okay, I'm gonna... Nope. That's good enough. Okay, so LCD power is basically within the quoted range of 0.4 milliamps. That's good though. Because that means that the calculations hold. Which is good for values. You know. Oh, I'm sorry. No, that was not milli anything. That was microamps, which is considerably lower than quoted. So what's going on with that? All right, let's start next, I guess, with the chip select signal. No, we'll grab LCD display because it's the easiest one to get to. And we'll plug LCD power in with the line we just stole. Tricky to get into. And this is kind of tricky to get into. Love that you can feel that click into place. So I don't think I have. Interessant. Now, why would you not work suddenly? Purple to black, black to black. Yep. Interesting. What have I done? What did I... Oh, wait. Yeah. Yeah. Ground to... Wait a damn minute. Ground to ground. What could the problem be? Right, step one, I guess, is take that off. And re-jump it. Make sure the pin's okay. This pin looks kind of bent now. What? Suddenly we just don't work, huh? Interessant! Did I just break my dev kit accidentally? I killed the LCD. Okay, comparison. That ground's not really seated, is it? Boy, this is just the jankiest possible way to take these measurements, huh? One tool, tree full. Top to top, red to red, yellow to yellow, orange to orange. So why were you working before and not working now? Fixed common is wired, that ground is wired. What are you two? Spy Mosey and Spy Mizo. Well, you're wired. The heck? Nothing. I don't know what I did to do it. I really fucked it up though. Okay, we're back to the really irregular pattern. I'm gonna shut this right off and just tinker with the wiring some more. So, red drops straight down to red, green stops straight down to green, brown and blue, brown and blue. 3 and 3, yep. Purple to ground, purple to ground. Purple to 3, purple to 3. Black to black. So I had this happen earlier and ended up reseating this little ribbon connector here. Oh, I wish I hadn't done that with it turned on. Thought I turned it off. So we removed this little guy and then we reseated him. And once he was seated and pure, we closed it up. These components are getting quite old. I've been working on this project for a very long time. So it's entirely... Yeah, there we go. That drew a screen. Alright. Let us... kill the damn thing. Okay. So this time, I want to check LCD display to LCD display. I have a theory that this is going to be really high. One of the theories that I'm working on is basically that I've somehow managed to make all of my like digital I/O pins weirdly current hungry in a way they didn't have to be. So what's the deal? Interessant. Interesting. Okay. Why on earth would that be? It should be positive voltage, so it should come... Oh, now I can't get the signal back either. Oh, let us think, my brothers and sisters. How else can we get this measurement? Nope, something's fucked. I'm not getting the signal I should get. Let's back up a skosh. I really should have turned it off before I did that. I guess if nothing else, this is filling me with a appreciation for the resilience of this design that I didn't have before. Yeah, that's what I was afraid of. This LCD unit might be dying, dude. I shouldn't have to constantly reseat this flex cable. Part of the reason I'm having to is that this flex cable shouldn't really be exposed to handling, but it is kind of right on the edge of a design that... Fuck off. That's great. I may have just cooked it. Dude, come on. Okay, that blinking light isn't really helping. It's sort of helping. It's showing me, so when it holds steady like that for a couple seconds, that is because we're actually on a screen that doesn't toggle that value. And then when it starts blinking after a couple seconds, that means it's working great. So, the good news is, for arcane reasons, I have another one of these LCD displays. Not the red, like the carrier board for it, but the actual display module itself I could replace in a pinch if I had to. Way! There we go. Alright, I don't really want to fuck with that anymore is the problem. Something about putting pressure on that ribbon cable is really messing with it. It's like coming unseated, it has to be messed with. But I also don't know how else to get that measurement. And I want it, because we haven't really learned anything. Let me think. I really want that measurement. How can I get that measurement? I know how to get that measurement. I know how to get that measurement without building this into a thing that... Yep, okay. Alright. That's not ideal, but it's fine. Okay, so... You know what I didn't consider? This thing has pins on the front. I can... Oh, do I have jumpers that are jumpers on both ends, though? Please tell me I do. What I need are... I think I have the opposite. I got a big tangle. Oh, this is a job for a... This is a job for a breadboard. That's why I don't have any that are male on both ends. Alright, let's try this real quick. What time is it here? We're getting up to 96 minutes. We're going to try this real quick. If it works, great. If it doesn't, I might wrap up for the night. We'll see. This is such a stupid solution to this problem. 3 volts in. Good. 3 volts in. Still good. Okay, you with me so far? I told you it was stupid. And then what solves this problem for me on the other end? What solves this problem for me on the other end is going to be the clip and the pin. But I've got them on backwards now. So hopefully that doesn't matter. Hopefully I just get measurements in the negative. That would be ideal. LCD power, great. LCD power. LCD display. Jump down 2. LCD display. Jump down 2. LCD display. One measurement I'd love to get, but I don't think I can. Like, the physics tells me that I'm not going to get it with this tool, is I'd love to know what the average current draw, like the mean current, or the effective, like, current per hour is of the SPY clock. I don't think we need to get so type A as to try and like minimize the data that's on the SPY bus, but like how much current SPY uses would be interesting data to me. And also, I think the only one I want from over here is this ground, which I'll put 2 there. Oh, I'm gonna need way more of these jumpers, aren't I? Oh, I didn't think of that. I probably don't have enough. Well, actually, this will be a good test too. Because if I'm right that external common doesn't actually connect to anything, then I might not need it. I guess we'll see. 8.3 volts. LCD power. Oh, but I can get away with this because I'm gonna have one that I never connect. This is actually a great... No, I need to connect them all to get the proof of concept. Okay, I need to connect them all to get the proof of concept. It's not the right kind. have enough. I don't have enough. Hopefully I got a couple more, because if I don't have enough. God, I'm starting to feel gross. Right, anywhere I see a square indie boy. Square indie boys are my ones that can do the thing. Square indie boys are the ones that can do the thing. Mess. Felt so clever when I took this kit apart and put it in this fishing bait thing, and now it really just made everything worse. Boy, my eyes do not want to focus on this at all. And yeah, I was right. I don't have enough to hook up the other side, so I guess we'll see if this even works. But I guess there's your proof of concept of something. So I'm also trying to, at the same time that I'm doing all this, I'm trying to make sure that I fully understand the nature of the circuit. Because eventually my circuit is going to overtake. Oh, that's interesting. Okay, so we're crashing when we're wired up like this. Ground to ground. We're crashing. Oh, this one's not connected. Hi, friend. You're just the LCD chip select, so you're probably not why we're crashing, but let's give it a shot anyway. Oh, I could connect. Interesting. Okay, so let's give that some thought. Let's connect external common. Oh, what? Why do you suck? Okay. Connect external common there with the pin immediately below ground there. And then really, can I find just two more of these crab gods? There's one. There's two. Look at that. Thank you, crab gods. Maybe I need to be praying to the crab gods. Just say. Because we're never going to measure this current, so I don't really care if it makes that much sense. Mostly care that I get video. There's only like 3 of these that I actually want to measure. Okay. Firmly connected there. We're all firmly connected there. Is everybody down on the bus? What? Did I just blow the battery somehow? Now I'm not posting at all. What's connected wrong? Wait, what? Oh, friend, you don't make no sense. Why do you work now? Jank box. Black, purple, gray, blue. Black, purple. Blue, gray. Ah. I see. That would actually break this entirely if that didn't work. That would stop communication outright. Those two are correct. Although I wish I hadn't used black. Both of them. Black, yep, black, yep. So the other thing that makes this kind of shitty is that this this breadboard is flaky. Best of times. It's all flaky. It's all super cheap stuff that I got. Like 2018 or 2019, I told my parents I wanted to get into electronics, and my mom was still super big on buying everybody Christmas presents, so naturally I got this guy. No, actually I didn't get this guy. I got just the bread box, the breadboard, and all these jumpers, and like a whole bunch of random passives. Oh, hello. You were never attached. And that is why this wasn't working. That's probably all that did. Oh, Jesus. Oh, great. You bent the pin, Patch. How does it feel to be the dumbest son of a bitch on the planet? Not great. Oh, it tried to light up. I don't know for sure that I need this measurement, man. No. How much of that is frustration talking and how much of that is actual? Do I need this measurement? Yes. I need to measure... I need to measure at least one logical I/O. You wouldn't think that I would want to put a resistor in the path of a signal. Because so... How should I put it? My calculations, my back of the napkin math, the MCU worst case is about 4... Worst case. This is if I'm running it at the speed I'm running it, and it's never pausing, it's constantly executing. It's like half of our power draw. And we're behaving better than that. And I saw in my earlier measurements, okay, so the earlier measurements were current draw. This is from battery terminal to ground, or however I measured it. This is the current draw, like battery pack in, battery pack out, because that was what was driving my my calculations for what drives what, right? So boy, that sentence didn't make any sense. What I was figuring out was how much the current drawn from the battery, so the two cells together in series, was. Which ultimately is like the determining factor of what capacity I need coming out of those batteries. Right? To get a certain amount of playtime. That was 20 milliamps. which to me seems excessive. When I unplug the display module, that dropped at the time to 14 milliamps, which means that something on this board here that I'm struggling to measure because honestly probably shitty equipment, something on this board here or the entirety of the board is drawing 6 milliamps. Now I know it's not the LCD power because we measured the power and we also looked the power up in other places, and the draw on the power is actually incredibly low, which tells me that I'm probably, by having written a sleep the LCD command that's kind of buggy, I actually probably gave myself more trouble than it was worth. I wish I'd measured that earlier. Now, what else is in that stack? Let me, I guess, just test something really quickly. I don't think this will actually post properly in this configuration. Well, it definitely won't post properly in that configuration because it's upside down. I don't think this will post properly in this configuration, but let's see. Red. Bunch of red, and then it goes to blinking. Okay, so as far as it's concerned, that's actually a valid config. It would be interesting then to take that measurement again. But I don't know if I want to. No, these would have no standby power draw because they're open. They're push to close switches. So yeah, whatever that current draw was came off the. Oh, but I guess power would bleed through the caps. How do the caps charge? The caps are inline. Nope, they're parallel to the switches. Okay, we have to look at a schematic. I said I wasn't going to do it, but here we go. Let's get a schematic up. Where's my mouse? Where is my mouse? Cool. I've never lost a mouse before. Oh, there we go. Okay, so let's look at a schematic real quick. I'll just throw the whole screen up. This is the wrong schematic. Let's find... daughterboard schematic. Oops. Daughterboard schematic? Uh-oh. Where is my daughterboard schematic? Projects, writing. Ooh. There's a force of habit for you. I've been doing basically all writing all the time for the last little bit. CAD sketches. It's not in here. Hardware design. Prototyping buttons. Dev kit. There we go. Okay, so they are in parallel. Huh? What? I guess these could be drawing current? I never considered that. I don't feel like figuring it out. I just don't. This wiring harness thing is a crapshoot. And this should be a solvable problem with math, right? Because we know... What's happening with these GPIO buttons? These GPIO buttons... I believe... They pull up or pull down? Now I need to look at the code. And, like, the really old code. We haven't had to do this code since, like, the early days of the project. I think these files were last changed in, like, 2019 or 2020. Where is it? Alerts. Display. Game. Hardware net. Human input.c. Oh, they were broken out a while ago. Okay. Clear interrupt. Those are just the ISRs. Where do I configure it? Oh, in hardware net itself, right? Okay. Set as input pin with pull up. Pull up. Okay, so they might actually have some quiescent power draw that I'm not contemplating. But I could calculate, right? I'm not crazy, right? Capacitors pass current. I'm sure they do. Let's see. I guess let's see. Pin 6.0 is one I need. This could be backward, but I don't really care. Is the situation I find myself in. Okay, so 6.0. It can't be much current because if there's an unresisted current, this thing usually browns itself out. Like, it detects that it's been monkeyed with, and it says, hey man, how about you don't? 2, 3, and then it goes to the fourth one. Yeah, there's nothing there. Oh, I should sweep it, I guess. Yeah, that's at its most sensitive and there's nothing there. Okay, so I feel confident in saying that the majority of the standby power loss is coming from something on the LCD board, and I need to know which one. But I can't know that without powering the whole board. Can I? I'm gonna need like a real... I don't know what I need. I'm gonna need like a real... Sorry, what I did, I took a measurement. I forgot to switch the camera back. I took a measurement and discovered that in fact there is no current draw from like button 0 to button ground. Signal input pin of pull up resistor, sensor battery pin. Yeah, that's fine. Snooze. I want to run another ad break because I've got a feeling I'm wrapping up soon. That's where that's going. I know it would be like an hour early, but I actually have a fair amount left to do this evening that I did not have time to deal with earlier. So we're going to have a slightly shorter than usual stream. Sorry. Where do I init spy? Display, see? Yeah, that configures all the pins. Data transmit pin. Toggle output on pin. Ah. Ah, that's different. That's not the same. So when you're setting up the GPIO ports, you're placing different registers in different states, and I think I'm willing to bet that if I got the right manual out, there's a difference between setting the output on a pin there's a difference between setting the output on a pin and setting the pin as an input pin with a pull-up resistor. Do I have that manual? I might not have that manual. Data sheets. Oof, no, that's not it. Docs? Nope. I've run into this problem before where I thought I had these all squared away and stored somewhere, and then I went to like reference them and they were gone. PETI documentation. Oh, that's my documentation. That's too bad. PETI helpers. That's converter code. Images. Oh, those are actual literal images. Business. That's business stuff. Okay. Is it just hiding in my downloads? Maybe. No. Okay. So. Yeah. All right. That's a good point to research on, I guess. I'm gonna have to send myself an email or something so that I remember. Yeah, so I'm willing to bet that I've hunted down the main problem. It sucks that I can't get a physical measurement, especially because I bought a physical tool to take that physical measurement. I've unplugged the headset again. I just want to plug this all back together and make sure it actually works. And then we'll find somebody to raid. That'll be fun. Okay, so anyway, I'm willing to bet that the main issue is... Oh no! Oh no! You really fucked the dog on that one, Patch. Bent a pin. So bending a pin is fine. These pins are pretty flexible and they can be flexed back into place. The problem is... if you somehow break continuity, that actually looks just fine. Yeah, that seems fine. So I need to crack this egg a different way, or buy new tools, is the gist that I'm getting. So I'm just going to write my theory down really quickly. I have a theory, a hypothesis, not a theory, excuse me. I have a hypothesis that principal issue here is going to turn out to be stop moving around. I have a hypothesis that the principal issue is going to turn out to be is uncontrolled output high to hot. Okay, so here's my theory. I've been wrong before. LCD power, if I look at that LCD power pin, if I bring up like the schematic, I don't have it at the moment, but if I bring up the schematic for the actual hardware, no, we're skipping that ad. If I bring up the schematic for the actual Sharp hardware, I'm willing to bet that if I look at what's hooked up to the LCD power pin, I'm going to find that there's either an inline resistor or some property of the LCD display, or yeah, the LCD display that is making it limit itself down to a very small current, because it probably doesn't need to be a current, right? It's already hooked up to the 3.3 volt bus, so it's probably literally just a logical signal, which doesn't need to have a lot of current behind it. I'm willing to bet that either my LCD chip select pin or the LCD display pin, actually, I can look at the code for that too, is set too high. Or not too high. It's just set up as like a, dear microcontroller, please keep this pin at 3.3 volts. And because of the laws of physics, that is calling for more current than you might otherwise expect, I guess is the best way I could describe it. So that's about that for that. Now, I think we're going to go raid our friend Cricket. No, that's not correct. That's not correct at all. How do I cancel? Cancel. We're going to go raid our friend Cricket _. And when we get over there, we're just going to say hi to him and be nice and polite. I'm going to crunch this, like the documentation part of this theory over the week. And we'll be back next week with some more of this. So, thanks everyone. You've been cheersy, and I'll catch you all tomorrow.